Bismillah. In this video I am going to solve Cambridge IGCSE Mathematics Paper 4 May June 19 Variant 3 The hardest question. First one III. During the journey the train takes 35 seconds to completely cross a bridge. The average speed of the train during this crossing is 90 kilometers per hour. The length of the train is 95 meters. Calculate the length in meters of the bridge. In this question, you have to know that the distance covered by the train to cross completely the bridge, not only the length of the bridge plus the length of the train. Because cross completely means the last car should cross the bridge. So for the last car to cross the bridge, it should move the length of the train plus the length of the bridge itself. So the distance should be covered by the train to cross completely a bridge equals the length of the bridge plus the length of the train. Now we have the speed 90 kilometers per hour and we have the time 35 seconds, so we can find the distance, but we need to convert the speed from kilometers per hour to meter per second. Now to convert from kilometers per hour to meter per second, multiply by 5 over 18, so 90 times 5 over 18 equals 25, so 25 meter per second. Now this is the speed, and we have the time 35 seconds. So to find the distance, 25 velocity times time, so 25 times 35 equals 875 meters. This is the distance covered by the train. This distance includes the length of the bridge plus the length of the train. So the length of the train 95, so to find the length of the bridge, 875 minus 95 equals 780 meters. Next one, 4a. The diagram shows a hemispherical ball of radius 5.6 centimeter and cylindrical 10 of height 10 centimeter. Show that the volume of the ball is 368 centimeter cube, correct to the nearest centimeter cube. The volume of the ball equals, because hemisphere, so 2 over 3 by r power 3, so 2 over 3 by 5.6 power 3, 368 to nearest centimeter cube. I. The tin is completely full of soap. When the soap is poured into the empty bowl, 80% of the volume of the bowl is filled. Calculate the radius of the tin. So this means the volume of the tin equals 80% the volume of the bowl. So the volume of the tin by r squared times the height, which is 10, equals 80%, so 80 over 100, multiply the volume of the bowl, which is 368, so multiply 368, equals 294.4. So 80% of 368, this means 294.4. Now you can find R. R equals square root 294.4 divided by times 10 equals 3.06 to 3 significant figures. B. The diagram shows a cone with radius 1.75 centimeter and height 6 centimeter. Calculate the total surface area of the cone. The total surface area of the cone equals the curved surface area which is pi RL, plus the area of the base, which is pi R squared. So surface area equals pi RL plus pi R squared. So to find L, the slant height, we have the perpendicular height 6 and the radius 1.75. Now from Pythagoras we can find the slant height. So L equals square root 6 squared plus 1.75 squared equals 6.25 centimeter. Now we have the slant height, so we can find the total surface area. Pi times 1.75 times 6.25 plus pi times 1.75 squared equals 44.023 significant figures. Double I. The cone contains salt to a depth of 4.5 centimeter. The top layer of the salt forms a circle that is parallel to the base of the cone. Show that the volume of the salt inside the cone is 18.9 centimeter cube, correct to 1 decimal place. To find the volume of the salt, you have to find the volume of the big cone minus the volume of the small cone. Volume of the big cone you can find because you have radius and you have the perpendicular height, which is 6. So for the big cone, 1/3 pi times 1.75 squared times the perpendicular height, which is 6, minus the small cone. For the small cone, we need to find the radius and the perpendicular height. For the perpendicular height, because the height of the original cone is 6 centimeter and the height of the salt is 4.5, now you can subtract to find the height of the small cone, so 1.5 centimeter. Now we have the height, we need to find the radius. Because the small cone is similar to the big one, so the sides proportional. So this means R1 over R2 equals height 1 over height 2. So if we consider this R1, so R1 over 1.75 equals height of the small cone, which is 1.5, over height of the big cone, which is 6. Now cross multiply. So R1 equals 0.4375. Now you can find the volume of the small cone, 1/3 by 0.4375 squared times the perpendicular height, which is 1.5. So equals 18.9 to 1 decimal place. Next, question number 5. The diagram shows the graph of y equals fx. Fx equals x squared minus 2 over x minus 2. A, find f1. F1, this means x equal 1 and we need to find y. If x equal 1, find the point on the curve which has x equal 1. So this is the point. Now find y coordinates, so -3. So f1 equals -3. This means if x equal 1, y equals -3. So -3. Double I, find f -2. So you need to find f -2 first. F -2, you can substitute in the function itself, or from the graph you can find. This is easier. So f -2, this means you need to find y when x equal -2. When x equal -2, y equal 3. So f -2 equal 3. So now we need to find f3. This means if x equal 3, we need to find y. x equal 3, y equal 6. So f3 equals 6. Now B, this is a tricky question. On the grid opposite, draw a suitable straight line to solve the equation x squared minus 2 over x minus 7 equals negative 3x. How to find the suitable line? To find the suitable line, we need the curve to the left, so the suitable line will be to the right. We know that the equation of the curve y equals x squared minus 2 over x minus 2. But now, this x squared minus 2 over x minus 7. So we need to rearrange this equation such that the equation of the curve to the left, so the equation of the line to the right. So keep the terms which included in the original function to the left. So now keep x squared minus 2 over x and transpose negative 7 to the other side. So 7 minus 3x. Now, this is not the curve. We need negative 2. We need to add negative 2. So add negative 2 for both sides. So now this is the curve. So this is the line. But we need to simplify. 7 minus 2 equals 5. So 5 minus 3x. And because this is the curve, so this is y, so y equals 5 minus 3x. This is the suitable line we have to draw. To draw this line, you need 2 points, x, y. Put x equals 0, so y equals 5 minus 3 times 0, so 5. You can put x equal 1, so y equals 5 minus 3 times 1, so 5 minus 3, so 2. Now draw this line 0, 5, 1, 2. 0, 5, so this is the point 0, 5, 1 and 2. Now draw the line and find the intersection between this line and the curve. This line intersects the curve at 2 points. Find the coordinates for these 2 points, the x coordinates for these 2 points. The x coordinate for the first point, negative 0.2, for the second point, 1.7. So negative 0.2 and 1.7. C. By drawing a suitable tangent, find an estimate of the gradient of the curve at x equal negative 2. This x equal negative 2. So this is the point which has x equal negative 2. Draw a tangent. Line touch the point. Then find its gradient. This is the line. Now find the gradient for this line. You can pick 2 points on the line. The first point, we can consider the first point, negative 2 and 2.8. So negative 2 and 2.8. One more point, for example, 1 and negative 7. 1 and negative 7. Now find the gradient of the line y minus y. So negative 7 minus 2.8 over x minus x. So 1 minus negative 2 equals negative 9.8 divided 3 equals negative 3.3. Next, number 7. A straight line joins the points A, negative 2, negative 3, and C, 1, 9. Find the equation of the line AC in the form y equals mx plus c. This part is easy. Find the gradient of the line y minus y. So 9 minus negative 3 over x minus x, so 1 minus negative 2, so 12 over 3 equals 4. So the equation of the line y equals 4x plus c. Now substitute by any point 1 and 9, for example, this x and this y. So 9 equals 4 times 1, which is 4, plus c, so c equals 5. So the equation of the line y equals 4x plus 5. B. Calculate the acute angle between AC and the x-axis. We have rule to find the angle between any line and x-axis. This angle equals tan inverse the gradient of the line. So tan inverse 4 equals 76.0 to 1 decimal place. And the reason, because if this x-axis and this is the line and this is the angle, we know that the gradient of the line rise over run, and tan theta opposite over adjacent. So tan theta equals rise over run, so this means tan theta equals the gradient. So to find theta, tan inverse the gradient. C. ABCD is a kite where AC is the longer diagonal of the kite, B is the point 3.5 and 2. Find the equation of the line BD in the form of y equals mx plus c. Draw the kite. So if we consider that AC is the longer diagonal, so this AC and this B D. Now the diagonals of the kite perpendicular, so this is the kite. We have the point B 3.5 and 2. We need to find the equation of the line BD. BD perpendicular to AC, and we have the gradient of AC equals 4. So the gradient of BD, because perpendicular to AC, so negative 1 over 4. So the equation of BD, negative 1 over 4 x plus c. And we have the point B 3.5 and 2. Now you can substitute. So 2 equals negative 1 over 4 into 3.5 plus c. Then you can find c. So 2 equals negative 7 over 8 plus c. So c equals, transpose negative 7 over 8 to the other side. So 2 plus 7 over 8, which is 23 over 8. So now y equals negative 1 over 4 x plus 23 over 8. Double I. The diagonals AC and BD intersect at the point negative 0.5 and 3. So this point negative 0.5 and 3. Work out the coordinates of D. In the kite, the longer diagonal bisect the smaller one. So this is the midpoint. So now we have the midpoint, negative 0.5 and 3, and we need to find the point D. So we can consider that D equals x and y, and the midpoint, negative 0.5 and 3. So negative 0.5 and 3 equals x plus 3.5 divided by 2 and y plus 2 divided by 2. So now x plus 3.5 over 2 equals negative 0.5 multiplied by 2. So x plus 3.5 equals negative 1. Then transpose 3.5 to the other side. So x equals negative 4.5. In a similar way, you can find y plus 2 over 2 equal 3, so y plus 2 equals 6, so y equals 4. So point D, negative 4.5 and 4.